Face retouching is one of the most widely used digital enhancement tasks, driven by social media, professional photography, and personal expression. Yet it remains a deeply nuanced challenge. How do we remove imperfections like acne, blemishes, and uneven skin tone, while preserving the unique identity of the individual, the subtle texture of pores, the natural glow of skin, the distinctive shape of moles or wrinkles? Traditional approaches fall into two categories: supervised learning and reinforcement learning. Supervised methods, such as RetouchFormer or RestoreFormer, rely on pixel-level supervision, training models to mimic labeled reference images. But this creates a fundamental flaw. They optimize for faithfulness to a label, not for human aesthetic preference. As a result, outputs often look rigid, oversmoothed, or unnatural, like a plastic mask with no texture, where skin appears flat and lifeless. On the other hand, reinforcement learning offers a more powerful alternative. By learning from human preferences rather than pixel-level targets, it can discover solutions beyond the training data. Methods like FlowGRPO use online reinforcement learning to explore diverse retouching paths, enabling richer, more adaptive results. But here's the catch. FlowGRPO introduces stochastic noise into the sampling process to enable exploration. While this works well in text-to-image generation, where diversity is valued, it's disastrous for face retouching. That noise accumulates over time, causing the sampling trajectory to drift from the high-fidelity manifold. The result? Visible artifacts, blurry details, and unnatural textures, especially in fine facial structures like the eyes, lips, and pores. So we're stuck in a trade-off: exploration versus fidelity. Can we have both? We introduce BeautyGRPO, a novel reinforcement learning framework that resolves this conflict through dynamic path guidance, DPG. A mechanism that stabilizes stochastic exploration without sacrificing the ability to discover better, more aesthetically pleasing results. At the heart of BeautyGRPO is FRPref10K, a large-scale, fine-grained preference dataset of 10,000 high-resolution image pairs. Unlike generic datasets that only assess global quality or instruction following, FRPref10K evaluates 5 key aesthetic dimensions: skin smoothing, blemish removal, texture quality, clarity, and identity preservation. Each pair is assessed by a combination of state-of-the-art vision language models and expert human annotators, ensuring alignment with real human judgment. Based on this data, we train a specialized reward model, a chain-of-thought reasoning engine that doesn't just score an image, but explains why it's good or bad. It reasons across each aesthetic dimension, providing interpretable feedback that guides the policy toward more natural, human-aligned outcomes. But the real innovation lies in dynamic path guidance, DPG, the core algorithm that makes BeautyGRPO work. In standard flow matching models, the sampling process follows a deterministic ode trajectory from noise to image. To enable exploration, FlowGRPO converts this into a stochastic differential equation, SDE, injecting Gaussian noise at each step. But this noise causes drift, deviation from high-fidelity regions. DPG fixes this by introducing a stability anchor, a high-preference retouched image selected from FRPref10K. This anchor isn't a target to imitate. It's a geometric reference point in latent space. At every sampling step, DPG computes an ideal anchor-guided ode path from the current state to the anchor. Then, instead of pure noise, it blends two components: a correction vector that pulls the trajectory back toward this anchor path, and independent Gaussian noise that preserves controlled stochasticity. The blend is time-dependent. Early in the sampling process, when structure is forming, the correction dominates. Later, as refinement begins, the noise takes over, allowing fine-grained exploration. This creates a dynamic, adaptive trajectory that stays close to the high-fidelity manifold, yet still explores beyond it when the reward signal suggests a better solution. The result? A sampling process that is both stable and exploratory, a rare combination in high-fidelity tasks. We validate BeautyGRPO across multiple benchmarks, FFHQR, and in the wild dataset of 1,000 real-world portraits, and a large-scale user study with 100 participants. Quantitative results show consistent superiority. On no-reference metrics, NIQE, NIMA, MUSIQ, MANIQA, TOPIQ, and NRQM, BeautyGRPO outperforms both specialized retouching models and general editing baselines like NanoBanana, Seed Dream, and Flux, K. Even on FID, which measures distributional realism, it performs competitively, despite exploring beyond the training distribution. Why? Because it's optimizing for human preference, not pixel-level match. Visually, the difference is stark. RetouchFormer and VRetoucher often miss blemishes or oversmooth skin, erasing texture. General models like NanoBanana or Seed Dream introduce synthetic, glossy appearances, like plastic. They misidentify moles as defects, alter facial structure, and produce unnatural artifacts. BeautyGRPO, in contrast, removes blemishes cleanly, without over-editing. It preserves pores, natural skin texture, subtle wrinkles, and moles. The skin has a healthy glow, balanced tone, and realistic gloss. Facial contours remain sharp. The identity is preserved. Eyes, nose, lips, everything looks like the person, just better. In our user study, BeautyGRPO achieved a 63.25% win rate, far ahead of all competitors. RetouchFormer scored only 8.5%. The model wasn't just preferred, it was consistently preferred across age, gender, and editing experience levels. We also ablated DPG. Removing it led to significant performance drops, demonstrating that stability is not optional. We tested different numbers of DPG steps. K equals 3 was optimal, offering near maximal gains with minimal computational cost. And crucially, DPG is only used during training. At inference, we revert to standard ode sampling. No anchors, no extra cost. The policy learns to produce high-fidelity results without relying on reference images. So what does this mean for the future of face retouching? BeautyGRPO shows that we can move beyond pixel-level mimicry. We can align image generation with human aesthetic preference, not through imitation, but through understanding. By combining a fine-grained preference dataset, a reasoning-based reward model, and a dynamic guidance mechanism, we've built a system that doesn't just edit faces, it enhances them with taste. This isn't just about removing acne. It's about respecting identity, about preserving the unique marks that make a face human, about achieving beauty that feels natural, not manufactured. BeautyGRPO isn't just a new model. It's a new paradigm, aesthetic alignment through guided exploration. And in the world of digital beauty, that's the next frontier.